Hello friends. As we know, the present rate of economic growth is unsustainable without saving of fossil energy like crude oil, natural gas or coal. There are many alternatives to fossil energy such as biomass, hydropower and wind energy. The increase in use of plastic products caused by sudden growth in living standards had a remarkable impact on the environment. Mostly thermoplastic polymer make up a high proportion of waste and this amount continuously increasing around the globe. The conversion of waste plastic into fuel requires feedstocks which are non-hazardous and combustible. Waste plastics are one of the most promising resources for fuel production because of its high heat of combustion and due to the increasing availability in local communities. In particular, each type of waste plastic conversion method has its own suitable feedstock. The production method for the conversion of plastics to liquid fuel is based on the pyrolysis of raw material. An alternative method is to change the plastic mixture into a reusable product via chemical process. As most plastic is originally created from crude oil, the simplest and most closed-loop solution is to be crude oil products that can be reused either to make more plastics or as a fuel. Only several types of thermoplastic undergo thermal decomposition to yield liquid hydrocarbons used as a liquid fuel. For example, polyethylene, polypropylene, polystyrene, thermosetting plastics, wood and paper. In this process, the thermal cracking process is occurred. Thermal cracking process without catalyst is used in converting waste plastic into liquid fuel. The two types of waste plastic, low density polyethylene and polypropylene is used the process by 50%. Weight. Both waste plastic are solid hard form. Collected waste plastic are cleaned using liquid soap and water. During waste plastic are cleaned is wastewater created. That wastewater is purified for reuse using water treatment process. First of all, the waste plastic are cut into 3 to 5 size to fit into the reactor from this shredder. A vertical seat reactor used for thermal cracking. This reactor is used for the thermal cracking of that wasted plastic. Temperature used ranges from 100 to 400 in this reactor. When temperature is increased to 270 degrees Celsius, slurry turn into vapor and the vapor then pass through the condenser. The vapor which are created in this reactor are passed through the condenser. At the end of we collected liquid fuel. From this condenser, the vapor of that wasted plastic which decomposition reaction is occurred, the vapor is condensed and the oil is collected in the main storage tank. Between 100 degrees Celsius and 250 degrees Celsius, around 20 to 30% of the fuel is collected, and then when raised to 3 to 25 degrees Celsius, the next 40% is collected, and finally when held at 400 degrees Celsius, the yield is fully completed. During the thermal cracking process, plastic portions are not broken down immediately because plastics have short chain hydrocarbon to long chain hydrocarbon. First stage of heat applied breaks down the carbon-carbon bond, break down slowly. As the temperature is increased, the long chain are break down step by step. During this thermal cracking process, some light gas such as methane, ethane, propane and butane are produced. From this state they are exhaust. By converting plastic to fuel, we solved two issues. One of the large plastic seas and of the fuel storage and the shortage of the fuel storage. The use of advanced emission control leads to an environment benefit where oxides of nitrogen and other polluants particles are diminished. Yeah.